almost 40 people online. I'm excited to get an update from the Taipei Tech team. I will be visiting there in May, early May. So I'll see many of you in person. I know Alan is from Taipei Tech is here with us in the lab now, and so that's pretty exciting to develop the collaboration directly with Alan and Michael, who have been at Taipei Tech. So yeah, let's get on with it and get the update.
Great. Okay, pass to you, Taipei team. And I know, Ian, maybe you'll share screen and go for it. And then City Science Network will have questions at the end as well too. So I think there will be a lot to discuss.
All right. Thank you, Maggie. Can you hear me?
Yes.
Okay, cool. So hello, everyone. I'm Evelyn, and I'm the program coordinator at the City Science Lab Taipei. And we're very glad to have this opportunity to share with you with our latest projects and updates. So the title of our sharing today is Navigating the Future, AI and Robotics for Urban Sustainability. So with the exponential growth in the field of AI, our goal is to transform the urban landscape by introducing innovative solutions to address sustainability challenges. So for robotics, from urban robotics to data analytics and then to LLM, we hope to enable the potential of integrating them all. So before we start our presentation, let me introduce you to our presenters today. We will begin with the robotic team. We have Eric, Morris, Homer, and Hal, and they will provide a project updates on the hardware robots and software modules. Following that, we have Roy, Ellen, Roger, and Ian. They will provide you with highlights of our progress in utilizing urban data integrated with AI to facilitate the data-driven decision-making process. So without further ado, I'll hand over the floor to Eric and the robotic team. Eric, the floor is yours.
Okay, so Ian, next slide, please. Okay, so hello, I'm Eric from Robotic Teams. Our goal is to create a cohesive robotic community that bridges various research domains and narrows the gap in implementing research outputs in the field of robotics. We have covered 5 different robots corresponding to 5 distinct topics, which is cybersecurity, autonomy, synth-real, digital twin, and education. While those robots vary in form, we have developed a modular infrastructure to address the disparity in our development process. Next slide, please. Okay, so this is our modularized infrastructure. It contains different modules for different purposes. For instance, we have localization system for robotics for robots with LiDAR, or Apple Tech for robots with camera. All those modules are based on ROS2 and XenoDDS, which is a communication middleware for different modules to exchange their information and sending messages to different devices without effort. With ROS2 and XenoDDS, we enable robots to communicate with each other, and this module system makes our robot development more efficiently. Next slide. Okay, so now let's start with our first topic, cybersecurity. Next slide, thank you. Okay, so yeah. So this is EVpi, a new generation of PEV. Right now, we are using it as a testing platform for cybersecurity. In this demo scenario, user can use vibration motor on its cell phone to broadcast an authentication code through vibration. And the millimeter wave radar on EVpi will receive it and decode it. If the authentication code is correct, EVpi will unlock itself for user. By the meantime, our dashboard will unlock and visualize EVpi digital twin. It shows several information of EVpi, including speed information, sensor status, and camera view, and lighting control, and etc. Okay, so right now is our collaboration with Yangming University on cybersecurity of campus. This is an intrusion detection system that can detect any abnormal signals such as DDoS by using its own machine learning model. Finally, this is our pedestrian detection. It reveals any pedestrian detected by EVpi and shows on the dashboard. Okay, next slide. Okay, so now let's move on to autonomy. Next slide, please. Okay, here we have Spark from Postman Dynamic. Right now, we are developing and testing different algorithms on Spark, making a full autonomous system and continuously extend our modular infrastructure. Also, we have collaborated with well-known semiconductor manufacturer and developed an autonomy facility inspection system, which suits in their scenario. Therefore, we can command Spot by simply click any destination on its own map and assign a task to do. Spot and this system will handle the rest of it and execute it. Okay, next, I'm gonna hand over to Morris for another research that we are working on.
Okay, thank you, Eric. Hi, my name is Morris, and I'm gonna start from Think to Real. And next slide, please. In addition to Spot, we also have another quadruped robot called Go2, made by Unitree. This robot is more compact than Spot and with more capability for us to study and control. Right now, we're planning to do research on different control algorithms with Go2 and dividing into how to design a quadruped robot, its control algorithm supported. So first, we're already starting out our study from simulation. And we're using NVIDIA Isaac Sim to simulate and test the autonomous system and that we are just talk about. So there's a few research topic we're interested in. So the first will be multi-map navigation and robot behavior tree in different scenario, and sim to real, NPC or LQR controllers, and reinforcement learning. And by doing those, we're trying to build well-structured development environment for our later research. Okay, next slide. And there's a few demo video for robot motion controller and autonomous system. And the first one will be a wheel-leg robot. It's tested at NVIDIA Isaac Sim, and the other is our autonomous system are test at the office scenes. And next slide. And I'm gonna hand over to Homer for the digital twin present. Thank you.
Okay. Thank you, Morris. Hello, I'm Homer, and in this section, we present the digital twin topic project. Next slide, please. Okay, so this project called Story Robo is an interactive Puppetry-supported storytelling platform capable of recording, replaying, and sharing story. Next page, please. So we designed this interactive robot based on personal experience. In my childhood, my grandmother used to tell me stories through puppetry manipulation, but those stories can no longer be a part of my life since my grandmother has passed away. And this made me contemplate that what if we had an interactive puppetry capable of recording the stories? So whenever I wish to hear those stories again, I could simply replay and interact with the puppetry. This would provide us with an opportunity to bring back memories and stories into our life. So traditional puppetry are limited by their reliance on the manipulation of a storyteller for movement. However, they lack design features to enhance interaction between the storyteller and the audience. And our project aims to address this by creating an interactive puppetry system that integrates computer-mediated technology. And we create a new interaction diagram. Sorry, okay. So we create a new interaction diagram for Story Robot, which focusing on the bidirectional interaction. The robot in this project were designed as a medium like a puppetry, which supports both storyteller and listener. and system can record its movement through the manipulation by storyteller and their voice. And the listener can just recall the story when they want to hear it again. Okay. Next page. So currently we have completed 2 basic functionality based on ROS2. And the first one is physical simulation. As demonstrated in the first video, when the storyteller manipulates the story robot, the system will record its movement. Once the recording finishes, we can replay it in the future, as you can see in the second video. And the second part is virtual simulation. And in this part, we can control the digital twin's movement through the tangible robot. So in the future, we can use this function with an interactive storytelling book. So the storytelling experience will be more interactable. And this project is ongoing with further development underway to enhance interaction and accommodate diverse usage scenario. Next part, we hand over to how to introduce the small robot research.
Okay, thank you, Homer. And hello everyone, my name is Hao. I am going to talk about project that relates to education. Next, please. So, this is Pangolin Bot. This is a platform for learning robots control and animal behavior research, designed to cater to students of various age. This robot offers diverse learning experience. Currently, it mimics the walking and the crawling behavior of a pangolin through motor control. Next, please. So I will introduce how it works. It achieves movements by using 5 servo motors. So in the video, you can see the robot can go forward and go backward or turn around. And by adding to more motor, it can turn its head to any direction. Next, please. And it is about curling mode. We use the middle motor to contract the tail for curling after its flip. So you can see the robot wiggle its legs and it will flip to left side or right side. And after that, we use the middle motor to grow the body. Next, please. So at the beginning, I introduced this robot can do some animal behavior research. So also we construct this robot with a module base, and it's allowing easy adaptation to mimic other animal by simply change leg size or outer shells. Next. So at the last, we have held some events, so such as course that talk about robotic basic knowledge and workshop for high school students to inspire them experience different area of interest. Also, we invest some expertise to have talk about robotics. So next, I am hand over to Roy.
Hello, everyone. I'm Roy. I'm the head of urban informatics. I'm leading the data and AI team, and we're going to share some of the projects today. Next page. So before we start to introduce the project themselves, I want to introduce our framework and our building blocks that we do and continuously evolve. The first, also the most foundational, is the spatial temporal database that we started to construct, which is a scalable and ever enriching real-world digital twin. We consider that as a sort of a core asset of the real-world context. Next. And in order to engage users, whoever the user are, we need to develop an intuitive and high-performance urban data viewer, which is a web-based kind of interface and allows a multi-model and intuitive and straightforward interaction. Next, and most importantly, we build different function modules to bridge the front end and back end. And these includes analytics and insights and visualizations, and lastly, simulation. And we use AI specifically, especially using LLM as a sort of functional driver to link the different components. And we use the database as a sort of the knowledge base to empower AI to equip them with urban knowledge, and the interface as a human AI interaction. Next. And so the three projects that we're going to share are sort of the manifesto of this overall structure. The first will be Urban Pulse Navigator, which is a AI-enabled interactive urban knowledge interface, where user could allow AI to automate the analytic process and extract insights directly from the spatial temporal data. Next. And for Urban Insights AI is a workflow that we try to use AI again to automate the process from complex urban events, data points, to become a knowledge graph for user to easily digest. A third one, next, will be Urban Mobility Simulator, which is a AI integrated, mass scale, but high fidelity complex urban system simulator. And we're going to introduce in detail later on. So I'll give the floor to Ian for the first project.
Okay, thanks, Roy. My name is Ian, and I will introduce how we build the Urban Pulse Navigator. So, okay, urban analytics is a complex processing that spans from data collection to providing insight for decision making. And we believe the large language model will be a game changer in optimizing this processing and enabling the public to easily obtain insight from the urban data. So to facilitate a more comprehensive analysis and application, we gather a wide range of urban data, such as building polygon and roles and point of interest, a lot of urban data, and to then a few. So after that, we use geoprocessing and geohashing function and to standardize urban data to each grid and to store them in the spatial temporal database, and which is a solid and extendable foundation for our application. So by providing coordinate, we can easily obtain and corresponding hash code, and which is spatial searching engine allow large language models can connect between grids and locations. And let me explain how our system works. So you can see on the left side, we have a feature that allows for the visualization of urban data in real time. So also, this system is activates when user click on the specific location on the map. And additionally, on the top side, this is a search bar, and by typing the name of district or location, user can quickly focus on a particular area within the city. Yeah, so if we ask the question to large language models, it can search location correctly. So the second part, City AI allow user to ask questions about urban data using natural language. So first, when a user type a question, City AI will classify the question and identify what kind of data set should be used. And next, and it will generate a code and visualize. Finally, we will get the summarized into insight, and all of this processing we use open source and fine tune with large language models to run on our local server. So, okay, this is also a clip. So you can see the demo. So I asked a question about the correlation between UVi usage and demographic on the specific area. So, and the City AI will provide the result and generate the visualization immediately. So it is very powerful systems for us to get the insight and don't use a deep technology. So, okay. So this is also the use case. So this is the real-time data about your bike. So imagine if you visit Taipei and want to renting the bike to ride, and City AI will calculate the real-time bike sharing information to suggest nearby available station. And also, this is a complicated questions about if I am the salesperson and I want to sell product for elders, which district is the best option. So City AI can use its knowledge to calculate the number of people over 65 years old. And it's not only consider the age of elder, you can see the grade one, and they also give us the suggestions, say we have to value another factor such as accessibility, competition, and purchasing power should be considered. So if we have more data set, it could analyze question comprehensively. And therefore, in the future, we are eager to enrich our spatial temporal database, including economic, social, and governance data set to empower the city AI. And next one, Roger will share how we use the insight base module to extract the insights for season content.
Thank you, Ian. Hi, everyone. My name is Roger, and I'm happy to share something exciting. So we know that there are numerous metrics to evaluate the development of a city, and citizens report is one of the way. Traditionally, citizens report are classified by agencies, which cannot fully reflect what citizens are concerned about. To capture the core issues, we propose a framework here we call Urban Insight AI to provide insights by visualizing the texture of the text-based data. With the combination of natural language processing, clustering, dimension reductions, and large language model, it enabled us to achieve this goal. Urban Insight is capable of visualizing the statistical outcome of the information, indicating the correlation between different things at a hyperspace, and filtering information based on different factors to compare. We would like to show you some examples of its capabilities. In this demonstration, it shows the proportion of different topics and their distributions in reality and at a hyperspace. The pie chart in the upper left corner is the proportion of 5 main topics. By choosing a specific one, we can not only see the distributions of that topic on the map, but also in the virtual space on the bottom left corner. In addition, we can know the detailed categories under that topics. By selecting multiple topics and filtering based on area or time, it can better help us to comprehend the correlation between different categories in the hyperspace and the pattern of responsive time from citizens. And we would like to tell more about the hyperspace, which is quite interesting. So in the virtual dimensions, different topics are represented by different colors. If we zoom in, we can see more details. For example, under the topic of noise and sound, we can see that it could be divided into karaoke, amplifier, and construction noise. Moreover, the closer the distance between topics, the more similar they are, indicating that these topics are likely to be highly relevant. Nevertheless, Urban Insight AI is more than that. By filtering based on area, we can compare two district citizens' complaints at a hyperspace. So the blue color represents an area 1, and the green color is area 2. On the right side, we can see the amount of each topic for both areas and the count of the report at different times. On the bottom left corner, the topic, noise and sound, green notes are apparently more than blue ones, representing that area 2 has more citizens complaining about noises. Moreover, taking a closer look, we can understand that most people are complaining about karaoke and amplifiers. On the other hand, as for the topic air quality concern, the blue notes are more than greens, indicating that the area 1 has more citizens complaining about air pollution. This insight is quite aligned with reality because area 1 actually is an industrial area. We know that citizens' responses are essential for evaluating the city, and this framework can indeed provide some insights and help us better understand the city. But among numerous issues, mobility is the most important thing for urban development. Next, Ellen will share how we think that we can mitigate this current dilemma.
Okay, thanks, Rogers. Hi, I'm Aaron. And next slide, please. So we all know that there are many different kinds of issues existing in cities, And however, we think there's one thing that cannot be denied is that mobility is one of the key factors to impact our lives and contribute many issues related to living quality, traffic, health, and the environment. In addition, with the global goals of achieving net zero 2050, it is essential for us to comprehend urban mobility systems. To analyze mobilities at urban scale, acquiring massive data is necessary. For example, individual data for people where they are living and how they go to office and where they go to buy lunch or some occasionally visiting places. However, collecting these kinds of individual schedule data requires a huge cost. Moreover, it will be restricted due to privacy issue. Therefore, in order to overcome these restrictions, we utilize various sensors and the demographic data sets to confine the outcomes of the results that LLM generated. To be more specific, we use large language model to confine the correlations between demographic features, including age, education, and the transportation mode usage. Or you can say that we let LLM generate synthetic agent profile based on demographic statistical data. So as you can see the image on the left side, without the confinement by LLM, demographic distribution variables constantly output some unrealistic agents with a person whose age is 3 but already earned a PhD degree. On the other hand, with the confinement by LLM, it will output the more reasonable agent. So here is an example of an agent. So after generating agents, we will start to determine the start point, which is living space by its residential distribution and the agent's incomes. And then we will determine the frequent destination, which is usually workspace for the agents by the agent's occupations and the working population distributions. And then we will try to find occasional places for the agents by using similarity search and the POIs model to calculate the most potential place that the agents will go. So with the above 3 steps, we can get the schedules with coordinates. Then we can use these coordinates as an origin and a destination to calculate the multimodal mobility behaviors between each schedule. So what if we generate 100,000 profiles and calculate their mobility behavior, simulate it on the cities? So this is our demonstration. As you can see, there are currently 100,000 agents moving around the city. And according to their schedules, and you can actually see the distribution by brightness. The brighter, the more agents there are. And we can also click a pause button to pause the animations, to click an agent to understand the agent's profile. Sorry, wait. Okay, so and the agent schedules will be shown on the left side, so you can also know what the agent is doing. And we also designed the route heat mode to make us easily get route usage insight. You can use the time slider to select the time intervals that you are interested in. So as you can see, this is a route heat map visualization, and we can also use the brightness degrees as an indicators to know what road segment is constantly used during the time interval that we selected. So on the left side, there are more information you can get, including the average distance that total agents have moved during this time, and the carbon emissions that they emitted. So, and we also can know the proportions of the transportation usage of the total agents, solar pie chart. And the pie chart is also interactive. You can choose a specific types of transportation modes that you are interested in, and the map will only show the route heat map of the transportation mode that we selected. So here you can see we click the walk, and then you can understand how agents work during this time. So I think that's all for our demonstrations. And in the futures, we know that one of the most important thing is to validate our simulations. So we are trying to design some sort of matrices that can evaluate our simulations quantitatively. And in addition, we can also make our systems transformative to predict mobility patterns through simulations. For example, maybe we want to create a new subway route in a city, and then we can use the simulation to understand how people use the new subway routes and whether the routes will really be beneficial for people and the mobility in the city. Yeah, and that's all for urban mobility simulators, and I will back to Evelyn.
Okay, all right. Thank you, Ellen. Okay, so I would like to recap. So for the robotics, we have discussed 5 distinct research topics. We talked about cybersecurity, autonomy, sim to real, digital twin, and education, each corresponding to a different robots. So we have EVpi, Spot, StoryRobo, and Pangolin. So all of these frameworks are communicated through ROS2 middleware, laying the foundation of our work, laying the foundation for our future urban robotic community platform. As for the data and AI team, Ellen just presented a live demo, actually. So I'll highlight the 3 projects that AI team talked about. So the potential of combining urban data and AI. So in Navigator, AI lowers the technical bar for anyone to access to urban knowledge. In Insights, AI assisted in automating complex information into hyperdimensional knowledge graphs. So in Simulator, AI enables a high fidelity and a massive scale agent generation for complex system simulation. Altogether, they depicted a promising future where urban knowledge can be democratized and urban policy can be enabled. So as our urban database continues to expand, the capability of our AI models will become more powerful. In the meantime, we're actively collaborating with local governments to deploy these tools and enhance our database. For example, we're going to initiate the development of SDG city metrics in partnership with New Taipei City government and the World Bank. So this will act as a tool that will serve as a practical model for cities to access, measure, and engage with various sustainability goals. And we would love to invite all the networks to join us in co-creating these metrics and shaping the future of urban sustainability. Thank you.
Thank you so much, Evelyn. Thank you to the whole team in Taipei. That was incredibly impressive. I think these presentations are really hard to do because you have such a short amount of time. And I know with this group, you've had so many projects that you've been working on that you had to present today. So really grateful to you for presenting, really wonderful to see all of the new work that you've done. We have time for Q&A. I'm sure there's a lot of questions, so I'd love for folks to let us know what you're thinking, what were your impressions of the projects, or what do you even see that kind of connected maybe to the work that you're doing? Also, certainly any questions that are more practical as well. What are we thinking? I can start with an initial question. It's very practical. For the work that you're doing with the LLMs and the AI, I didn't understand if you're currently using a data set to inform that, or if you're generating and creating all of your own data and you hope that in the future you'll be able to validate it more with real world data. So very practical question from my side, but just wondering for the folks who presented, Roy, Alan, and the others, are you currently using data sets that you have about Taipei, or you're generating everything in that tool to kind of see if you can model it and make it work?
If I may go first, Ellen, you can jump in later.
Okay.
Is that okay? Yeah. So to answer that shortly, we have both. Because generally LLM doesn't really have the knowledge of geospatial context. It does have a knowledge based on keywords or words, but it doesn't really know, for example, which bike sharing station is next to a road, something like that. So we need to build up a context-based database that has a time label so it can process further analytics. So we prepare the real-world data, and that's sort of the core assets that can empower LLM, the knowledge that it doesn't born to have. Yeah, so that's for that. But for agent-based modeling, we use that in different sectors. We use that to generate profile that LLM use its own common knowledge of how a grown-up with a certain income would behave throughout the day. Use that common sense, but confined by the real-world census data, saying we have a certain percentage of adult male living in certain area. We have that census data. So we sort of combine the both to generate high fidelity agents at an individual level. Yeah.
Very clear. That's helpful. Thank you. Thanks, Roy. Other
That's
thoughts or
great.
questions? Kent,
Well,
go ahead.
Maggie, I just want to echo your comments because I think these presentations were just really beautifully organized with excellent graphics. I mean, it was very impressive and some really, interesting projects. I know that the project to find insight from the residents' complaints, that potentially is a very important project. I know Boston has struggled to make sense out of all these thousands of calls they get with a similar system. And I think this could be very important for cities. Well, for example, the urban mobility simulations that Alan presented were impressive. I guess I would ask the team, this is moving so quickly that what is next? What capabilities do you hope to have in 1 year that you don't have now? Maybe Alan, you take that on.
Okay, so I think the next for the urban mobility simulators is that we want to try to design some matrices to evaluate our simulations or use some ground truth data sets to validate our simulation, because we don't really understand,
Yeah.
how's going on in the agent-based model and in the agent-based model, in the agent-based simulations, and then we don't really know, the accuracies of our simulation. So
Yeah. So validating the models.
yeah, validating the model.
So what strategies are you anticipating to be able to validate it?
So we are collecting some vehicle detectors data in Taipei, and then the vehicle detector data will give us how many cars in the road, and then we will use those numbers to estimate the occupancies in the road, and then use that occupancies to validate our heat map, our route heat map, as just like you saw in the demo, in the demonstration. Yeah.
Great.
Yep, Ken, I would like to, so basically we are currently working with New Taipei City. There's a new built science campus inside the city. It has 2,000 Foxconn employees. They did a detailed travel survey on where they live, who they are, how they travel, what kind of mode and the time spent. They also did a detailed survey on the road traffic. And then, so we're planning to, so basically imagine the system that Ellen is building using agent-based simulation and is populated based on this demographic data. And that allows to, and these 2,000 employees, they have to go to certain destination for work. That's actually a very good, it works as a good benchmark. We'll see how close we are to compared to the travel survey. And since it's Foxconn, So it's easier to actually dive deeper into the data set as well. And this project was proposed by the City of New Taipei, not by Foxconn. But coincidentally, it's a Foxconn factory campus. So I think moving forward, that would be one of the potential direction. And also, some of the graphics are actually generated using code generator, DeepSeek. So it's another large language model that allows you to generate different codes. And then although the robotic team is not there yet, but then we're planning to meet in between, we're planning to meet in the future where the DeepSeek can generate code for the decision tree that Maurice is building. So right now it seems like these projects are actually a little bit separate, but in fact, using large language model for data generation, augmentation, scenario simulation, scripting, and data annotation, and all those kind of stuff are actually what I see is really interesting moving forward.
Fantastic. Great.
Wonderful. Hector Antonio, I see you have your hand raised. What was your question?
Yes. Well, first, let me congratulate you for the presentation. I think that it was a very well explained presentation. But my question is about the urban pools. I think that was the name of the project. And more specific, I'm curious about the demographic data that you are showing. You show a graph about the number of elderly people in that district. Where do you get that information? Are you using census information? And if you are using census information, how do you deal with well, here in Mexico, the census is, Mexico did a census every 10 years. I don't know if in Taiwan, it has a shorter, shorter doing resolution, but how do you deal with this problem, and if you're using census information?
Okay, I can answer this. In Taipei, because we were demoing with Taipei data. In Taipei, the district level administrative, they have a census data updated every month. So that's how we get the latest data sets. Yeah.
Okay, thanks.
I know folks are always thinking about that question in different parts of the world. I see a hand up. I see a mic open. Who wants it next? Marcus? Luis? Marcus, then Luis.
Hi, thank you very much for the presentation. It was wonderful. I'm interested to know a little bit more about the SDG modeling and some of the simulation you're doing with Taipei City, or how that work is developing, and what are the data sets you're using to kind of build the simulations, and like what are they around?
So we collect a lot of demographic features like age, education, and some transportation propulsion usage, and then we use this demographic data to generate and then large language model to generate synthetic agent profile. So the agent profile that we generated will be matched with the Guangqiu's real world demographic data. And then we use some transportation data, and then we process it. We process the Taipei transportation data into GTFS format, and then run the multi-models transit algorithms on it to calculate the multi-models transit mobility behavior. Like someone may go to walk to subway, and then take the subway, and then maybe transfer to the bus, and then arrive at destinations, something like that. So this is just a raw whole process of our simulations.
But what is the actual SDG part of it? Like the metrics around the sustainable development goals, like how does that tie into that framework?
Yep. So Marcus, I think what Alan just described only talks about the mobility carbon footprint part.
Yeah.
But then in terms of the greater SDG related project, so it's a very new project that the city just confirmed giving this initiate this project to the lab in Taipei. But then the plan is that so on one hand you have this voluntary local report, VLRs, and every city has one. Every city try to look at their sustainability development from their own point of view. And then so this is like equivalent to a whole bunch of text, right? And then on the other hand, you have like a report. And then also you have the UN 17 SDG goals with subcategory and then subcategory 1.2, 1.22, and then stuff like that. So basically right now is embedding. We'll try to basically grab all the metrics that's available over there, including UN, including World Bank, and then a local report. And then so find the coordination between all these metrics, and then use something similar to what Roger just showed, like navigating the inside and then see the proximity, see the similarity between different index. And so the goal is actually to design an index that's generated, and then based on whatever content you feel you feed in. And then so for example, what the team is imagined is that you can simply ask, like, what's the give me examples of like the Taipei development in Taipei that match SDG 7, for example, and then the system basically pop up a whole bunch of information that's related to SDG 7. It could cover it could cover a wide spectrum of different topics. But then so depending on how you perform the search engine and how you actually do the clustering and grouping. And then this is the ongoing progress. And then to be honest, I'm not so sure what I'm doing, and the team doesn't sure what they are doing, and this is why at the end, Evelyn is actually, she wants to call for proposal, call for collaboration, inviting people to hop on the project, and then see how we can all work together and try to make sense.
Yeah, that sounds like a great collaboration project around how to develop a tool for SDG assessment, I guess, for cities.
Yeah. And the goal is actually design the assessment that without us making any assessment. Right. But then having people the freedom to generate their own radar plot to compare different aspects, of the SDG.
Awesome.
Very cool. Thank you. Thank you very much.
Thank you.
Okay, questions keep coming in. So let's go Luis and then Yarmo.
Well, congratulations. This is mind-blowing. Michael and the team, this is amazing. So, and I think it could be fantastic to have like a specific kind of presentation for each of them, of these projects, because they are so complex and interesting. I am very interested on the hardware and the robotics and everything that you guys are doing. You're always, Taipei Tech has been always amazing on that. So my question is, well, the next generation PV or is EVpi. I like it a lot. So how that? Maybe Michael, you can talk a little bit about that. But that's super cool. Congratulations about that. And also, I like how this project with the robots and the kind of like the teddy bear and the puppets. I think that's also pretty cool. So I don't know if you can talk a little bit about that projects and explain a little bit better, like, what is the origin, but I think that's very powerful.
Yeah. So I guess I'll just talk about this project for the team. So for the past 2 years, actually, what the team has been doing in Taipei is to try to evaluate all the sensor module, hardware modules, and open source codes, and then try to redefine the light autonomy architecture and the framework. So right now, all the robots in Taipei is running on ROS 2. And then so using Zeno allows different robots to communicate with each other in real time. And then so that enables a family of urban robotics, including like household robotics, urban robotics, and then different type of robotics. And then the mission for I believe when I spoke with Ken, the mission for the City Science Taipei should be focusing on talent incubation, but reaching out to high school students or like different robotic community in Taiwan. And then so that's why we're using, I asked them to use off-the-shelf components and then try to organize the GitHub. And then so making sure that even a high school student, even even the high school students, when they show up, they have enough instructions and hardware and software to build their own robot. And then, of course, you need to have this digital twin that's inside the digital world for storytelling. And then, of course, the developing. So the research question is actually developing the large language model using it to control robot. But the actual engineering, the engineering effort is actually to come up with a standardized modules and both software and hardware that we can share. And then, so in fact, we just talked to Huang yesterday from Guadalajara. And then he also shared about his adaptive control. They're using large language model for simulation for autonomous vehicle. And then there's a lot of synergy right over there. But the problem is that school like Guadalajara doesn't have Spot, doesn't have Unitree robots. And then it's very expensive, and then sometimes very troublesome to ship all these components around the world. So what we imagine is that we could offer a family of like smaller, low-cost robot that can actually talk to the big boys who has expensive sensor, and then but enabling the students, like college students, Europe, even high school students, to build their own robot, because I think that allows everybody to co-create this robotic family for the future. Right? It doesn't have to all the ideas. We don't have to reinvent all the ideas. I mean, we could offer a couple of tools so people can reinvent on it.
Awesome. Okay, Yarmo.
Okay, thank you. And thank you for the amazing presentations and amazing works. I mean, I really appreciate this. And my question is, or comment more, is this urban mobility. I've been working a bit with this this type of workplace understanding how the people use the city. And my question is that can we forget the people if we focus on activities? So don't think this agent as a person, as a people, but it's the agent is activity, going to a meeting, having a break, talking with people. Can you cover that area to go deeper in the micro level of these activities and extract that somehow within the kind of mobility? Okay.
Ellen, you want to go?
Sorry, I didn't get the question.
Yeah, quick answer is yes. Right now we're based on individual, and we do the profiling based on individual agent, and we do the scheduling afterward, all based on individual agent. We assume individual has a 24-hour whole day to plan, but we can always extract a certain activity from there because we already have that model. The result, we can extrapolate the similar activities, and maybe like as you said, a similar activity, where do they happen, so that we are not looking at individual at a massive scale, but looking at activities types and whether or not those are correlated with a certain area of the city and how that has to do with the urban transportation. So that's something that we can further explore, and that's also a very interesting angle. Thank you.
Thank you. Very good.
And then if you can do that, you could have the agents form relationships that would change their behaviors,
exactly,
activities that they engage in, and the simulations could evolve over time, just like human relationships evolve.
Yeah, in fact, one of the flexibility of what we do right now is that the entire workflow can easily be manipulated, saying we're not just modifying certain road networks, but we're relocated some of the land use or relocated some of the buildings into other places. So we can manipulate the city in the way we want it, using the same algorithm and fine tune it. Yeah, so that's there's a lot of potential.
Great.
Wonderful. So we're about at the top of the hour, and there's actually some conversation going on in the chat. So I see Kai has been asking about compute time. Tomas is asking about adding the LLMs to the storytelling robots, which is getting a lot of likes. And maybe most importantly, I saw Naroa asked early on about where's the documentation of the work. So has it been published and is it online? And it sounds like from the Taipei team, you're sort of in process of that, but you've been really busy. But most importantly, there's a lot of interest from the folks that are on the call today to learn more about the work that you're doing. So we'll certainly share the video of this call, but I think anything else that you have that you can share with folks here, it sounds like there's definitely a lot of interest. And we can also make some connections if you're open to having additional conversations, whether it's with the folks at MIT, with the folks in Chile. That would be wonderful as well. So if the researchers from Taipei, if you can stay online for a bit, we can see if folks want to stay and ask those additional questions. But for the big group, I do want to let us go as we're just about there. So great to see you, everyone. Next month, remember, we're here with City Science Lab Guadalajara, so that's April 30th, and some other things coming up in the meantime too, so I'll keep you posted. And congratulations again to the team in Taipei. Good to see you all.
Thanks,
Stay
everyone.
online if you have questions. Thanks, Kent.
Thank you.
Thank you.